Hello everyone, so welcome to my YouTube channel. In today's video, we are going to solve today's problem, that is today's LeetCode problem, that is 2196, create binary tree from description. So we are given a 2D integer array description where description of I is the first element is the parent, the second element is the child, and the third element is will say it is a boolean. We can consider it as a boolean value. It is left. If it is yes, then its value will be one, and if it is no, its value will be zero. Indicates a parent I is the parent of children of binary tree of unique values. Okay, it is the most important part of this question. We are given some unique values. The values are not being repeated. We are giving a unique value by binary tree. If it is left is equal to 1, then it means that child is the left child of the parent. And if is left is 0, then child is the right child of parent. We have to construct the binary tree described by the description and return its root. So our return type is here. Our return type is not array or something. We have to return the tree node. That is the pointer value. We have to return the pointer. So the test case will be generated such that binary is always valid. This was the question. Let us understand by using some example. This is the we are given this description. Let us match how we can create this tree. First of all, consider it as a parent. So 20. Okay, so I am going to draw here. We will be given 20 as a. This is the first node we encountered, and then second child is 15 and it will be in the left hand side, so we will get something like this. And in the next array we are given with 20, that is the parent itself, and then we are given as 17 and it is 0. It means it will lie in the right hand side, so we will get this tree something like this. Again we are given this 50. So we have encountered this element, this 50 for the first time. So we will create this node first, and then we will check whether 20 is existing or not. If 20 is not existing, we will create the node. But if it exists, then we will just create the link between the nodes, and it should be in the left hand side. So we will create something like this. Then again, we will see 50. 50 is the node exist? Yes, the node exist. We will then iterate and check 80. Does it the node exist? No, the node doesn't exist here. So first of all, we will create the node. And where we have to attach? We have to attach at 0. It means at the right hand side. So we are going to attach like this. Next, next element is 18. Does the 18 node is existing? Yes, 18 node exists. And 19, 19, does the 19 exist? No, 19 is not existing. So first of all, I will create 19 first. Then what is the value? Is what we are going to is it left or right? The value is 1, so we will attach it to the left. So this is our result. Resulting tree is this. So how we are going to solve this? The prerequisite for this problem is, first of all, we should know the concept of using unordered map. So we can solve this problem by using a one on ordered map and a unordered set. How we are going to use this? Because we should know that whether this node exists or not. So for creating a node, whether it exists or not, we have to remember it. So whenever we are going to remember, so first of all, we have to remember the value of the node and as well as the pointer pointing to this address of the node. So we have to remember two things. So in unordered map, we will create a map of int and a tree node, a pointer. So this int will help us to find that particular node, and this tree node will give us the address of the node. So this is how we are going to use the unordered map. And unordered set will be where it will be used. It will be used at the last to find the parent node. So I will tell you how we are going to find the parent node by the end of this video. First of all, let us create this node, create this tree. How we are going to create this tree? So let us first of all let us discuss the time complexity of this problem. Okay, we will discuss it later. First of all, let us see the code of this problem. So this is the code of the problem of this problem. Let us understand how we are going to solve it. First of all, I have created an unordered map of int and tree node. So this is basically a map. We are going to store this as a map. This will have the integer value and the address uh, of the tree node. So we are going to create this table. First of all, okay. So let me take the test case here itself. So our test case is 2015-1. So okay, first of all, let me take this from here itself. Okay. So yeah, we are going to find, let me just have this description. So we are going to yeah. Hmm. So here is the input of our input. So let us go through the example. Yeah. First of all, yeah. Let's move on. Hmm. First we encountered the 20. So if map.count description, if this I0 means we are referring to the parent, this I1 means we are referring to the child, and this I2 means we are referring whether it's a left child or it's a right child. So whenever we have encountered 1 0, we are going to see that if this map, if it exists in the map or not. This is our map. So first of all, we will see that map exists or not. In the map, this node exists or not. No, the node is not existing here. So we will create this node by by writing t node star node equal to new tree node. By this we can create this node, but after creating the node we have to assign the value of the node. So the node value will be description of I and I0. It means that first of all we encounter 20, and we will input some address. Let's suppose it is the address of the 20. So we have encountered the 20 for the first time, and we are creating the node for the first time. And we are putting the address into the our map. So we are done with this part of the code. And then we have encountered I1. I1, what is I1? I1 is a child. So we have got 15 here. So 15 exists in the map? No, 15 doesn't exist in the map. So will create we will add the index, and we will add, these are some random values. Writing this. It is representing the address. It is not something, it is not something absolute. It's just a random value. It can be anything. So this is the 15. So we are going to add 15. Then after we will check. It is, if it is 1, it means that it is a left child. So as you can see, MP12 is 1. So it is a left child. So what we are going to do, we are just attach 20 with 15 and so on. So this array will be completed. Now let us check 20, 17 and 0. If mp.count I0 exists, so we will check whether 20 exists for the second vector. Yes, it exists. So we are not going to create another one. We will check 17 whether 17 exists. No, 17 doesn't exist. So we will create the 17 and add some and the pointer address to it. Now we will check whether MPI2 is 1 or 0. It's 0. You can see if it exists, then it's the left, and if it is 0, then it is the right. So we are going to add 70 on the right hand side. By iterating the complete loop, we will create this by this piece of code. We will create this no create this binary tree, but the main reason lies in how we will return our parent node. So the concept behind is this, because we have to find the parent of this complete binary tree. So if it is a parent, it will never exist in the second place, because in every place there is a parent, and in the second place it's a child. if a parent exists if a parent exists in the child's place, so it cannot be a super parent. Let me call it as a super parent. So if a parent can exist in the child's place in any other in any other array, so it cannot be a super parent. For existing as a super parent, the node should be in the first place only. So it should be on the first place only in the complete vector or in this complete 2D vector. So we are going to search. So first of all, I will insert every child in this my child set. Now I will check whether parent exists in the child or not. If there exists some parent within the child and we couldn't find any other parent, so it will be a null. So we will return the null because it cannot be possible. It will be a cyclic graph. If every parent is a child of anyone, then it will be a cyclic graph. And here it has been given that it's a valid binary tree only. So we will return null. However, this statement will never executed. So if we don't found any, if we don't find any parent as a child in any of the vector, so we will return the 1 0. So here we will return our solution. So this was the solution of the bind. We have to of the solution of the problem number 2196, in which we have to create the binary tree from the description. So let us talk about the time complexity and space complexity of this problem. So we have to iterate big of n times to store in our hash map and big of n times to store in our set. And at last, I have to iterate big of n times to find the parent root. Or I can say parent or the super parent or it's a root. So at max, I have to iterate 3 times of big of n, which will be eventually lead to big of n time complexity. And for the space complexity, I am using an extra hash set and extra hash map, so the time complexity will be big of n. So to solve this problem, it takes big of n of the time complexity and big of n of the space complexity. Let us check this code and let us run this code on on the LeetCode platform. So as you can see, it is being successfully accepted for the pre-test cases. Let us submit this problem. So yeah, it get accepted. Thank you.